So if conditional statements were something to wrap your mind around, this next topic is sure to make you loopy. That's loops. We're going to be talking about how we can do all kinds of neat, repetitive tasks thanks to the power of loops, such as using counters, working with lists, and changing conditions so that we don't end up with infinite loops. So we'll have some new syntax, keywords, and structures. So as an overview, loops are used to create sections of our code that will process repetitively until certain conditions are met, or based on a condition. Now, if that condition never changes, we could be stuck in an infinite loop and crash the script. So we should be concerned, or we should be sure to consider, should we work with a counter and end the loop when the desired count is achieved. So an example of this might be that you're supposed to run a certain number of laps around the track, right? So if your goal is to run 1 mile, perhaps you're told, all right, keep running until you have passed the start 8 times. So you've run 8 laps around the track. So you're going to run, and when you pass that first start line the first time, well, your count is now at 1. And then you're going to repeat that until the count is now at 2. And then you'll repeat again. And you're told to keep doing that until your count gets to 8. Okay, so then you stop because you don't want to keep running and running forever and ever. And unlike you, a computer will never actually get tired and just quit. We have to actually tell them to quit, and that's when our script crashes. Same thing will happen to you if you keep trying to run around the track, especially if you're like me and have not been practicing. Okay, so that's an example of a counter, and in our code we'll have situations like that. Very similar to this is working with a list. And I say it's similar because if you think about it, if we're going to kind of repeat a set of tasks for each of the items in a list, then essentially we have a counter. We have a counter that says, continue this for each item in the list, essentially, as long as there are still items in the list, or if we knew that there were 7 items, we might continue until we were out of items. So this is a very similar idea to any kind of itemized step that you might follow. So, for example, we're going to say, here are 8 steps that you need to accomplish. So you're going to do all of the tasks in one, and then you're going to look for the next step and do all of those tasks, and so on and so forth until you get to the last one. And when you're at the end of the list, you go, oh, no more tasks. I guess I'll stop that loop. All right, same thing goes here. So this is a very, very common kind of loop that we'll be working with. We'll spend a lot of our time looking at examples like this where we're using a list as the basis for the repetitive action that is supposed to occur. And last of all, there's a looser way to simply work based on an overall condition. And as long as that condition continues to be true, we will continue to repeat. So the idea here is that we're going to make sure that the variable that is the kind of condition does eventually change or has the possibility of changing so as to finish out the loop. So this is the kind of thing that happens when, for example, I give my son a timeout. He's supposed to sit in the timeout until I tell him that it's over. So periodically, he gets distracted and he plays for a little bit or thinks about something else. And then, oh, he remembers he's in timeout and he stops and says, is it done yet? And I say, nope, not yet. So the condition has not changed. You're still in timeout. Keep being in timeout. Eventually, though, the condition changes and I will either tell him, okay, you may now get out of timeout. And then he can end the timeout loop. And of course, if that loop went on forever, I would have a very sad son. I would have a crash script. So we want to make sure that the loop does eventually end, right? So it's something we want to watch out for in that looser kind of loop, that we have a variable that is actually likely to change during the course of the loop running. Several examples here, and let's look at the actual structure for these. The first structure is a vanilla structure built into JavaScript, like what we've been learning with conditional statements last lesson. Now, we have this one that's built into JavaScript. We'll have another example that does the same kind of thing with lists, that is a handy utility built into jQuery. So we'll get to that next. But first, the for loop. This allows us to define a loop that repeats based on a counter. And it looks a little bit complicated, but that's only because this structure has a couple of slots that allow us to define all of those parameters. So the first slot here inside of the for, so let me back up. We have the for keyword that initiates this structure. Then we have a set of parentheses, and inside the parentheses we have 3 placeholders, each separated by a semicolon. After the parentheses we have a curly brace set, and then we put code inside of the curly brace set that will repeat for each iteration. So let's make sure we're on the same page about that term, iteration. An iteration is a particular time that we are moving through a repetitive task. So the first time we complete the steps of that task, that would be called iteration 0, or you might call it the first iteration. But remember how with arrays we usually start counting at the 0th item, or we start at 0. We're going to do the same kind of idea here. We're going to have an iteration 0, and we're going to increment and count up from there. So here we go with the structure then, those 3 placeholders inside of the parentheses. The first one allows us to define the counter variable that is going to be used. It is very often simply defined as the variable I, representing iteration, and it's assigned 0 to begin. So imagine the var I is assigned 0 goes right up there in that placeholder 1 before that first semicolon. So we've defined I as the counter, and we're starting it at 0. Then the second placeholder is going to be a condition. That is going to set the boundary for when we should stop, so or how long we should continue. So in this case here, it's going to look something like this, while I is less than 10. So what we're saying is we're going to repeat this loop as long as I is less than 10. So it's going to start at 0 and count up by some mechanism. We'll talk about that very next. But as long as I is less than 10, we'll continue the loop. When I is at 10, we do not continue any more. So if you think about it, if I is going to increase by 1 each time, that means that if we start at 0, we will have essentially run 10 times, because 0, and then 1, and then 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 10 iterations. So even though it starts at 0, that's why we use the I is less than instead of less than or equal to. If we set the number here that represents the number of times we want it to repeat, and I starts at 0, then we can kind of fix it and forget about it and know that I is going to count up and will stop after the 10th iteration or before I is 10. So that last piece there then is how the counter actually changes. In the third placeholder, we place some operation that changes the counter, and the most common thing that we do is that we want to just count up by 1, so we have the I++. And this is where, if the increment operator didn't seem useful to you before, this is certainly where that becomes very helpful. So we have a counter I, and we're going to increment it by 1 every time, and we're going to continue this until I is equal to 10, and when it's equal to 10 we're going to stop. So then last of all, placeholder 4 is for all the code that's going to process on each iteration. So we can do this with arbitrary numbers like what we have here, where we're just saying continue this and repeat it 10 times, and we'll practice that in the slides in a moment. But the very common thing that we do is work with an array. So imagine that we've defined an array here. Let's say that it has 7 items in it, items 0 through 6. Then we can say, so we're going to have a loop, a for loop, and we have the counter variable declared as I, and it's set at 0 to start. We're going to continue as long as I is less than the length of our prices array. So if we had 7 items in here, that prices.length is replaced with the value 7. So we're continuing as long as I is less than 7. And of course, we're going to increment I each time. Now, take a look at what's happening then inside of this. Notice that I guess I'm doing a couple of funny things here. But the very first line is the only thing to be particularly concerned with, where since we're working with a list, we want to go inside that list and grab one of the items out, essentially the current item. So that very first line there, var before is assigned prices sub I, is basically saying we're getting the current item. So on iteration 0, I will be 0, and we will therefore get the 0th item out of prices and assign it to before. Then the rest of the thing processes, and now we're on, at the end, we're repeating around, we're on iteration 1, which is the second iteration, right? So I is 1 now. Is I less than the length of prices? Well, as long as prices is, something more than 1, then yes. So we would now have 1 stored in I, and therefore this first line here gets processed again. Var before is assigned prices sub 1, which would be the second item in prices. So on and so forth. We would repeat this as long as we have items, and we would stop when we exceed the number of items. Okay, so that is a for loop in the JavaScript structure. Let's switch over to Codio and give it all a try. So here I am in the lesson 10 demo file, and we're just going to practice with for loops first of all. So let's create a loop that prints every number between 1 and 50 to the console. So we're going to use a for loop for this. And remember, we have the 3 placeholders. The last one is always going to be I++. Now what we do for the other 2 is going to depend. Very likely we'll start with var I, but you know what, if we want to start at 1, we might as well set I to 1. So starting at 1, now we're going to continue. We want to show 1, let's see, every number between 1 and 50. So let's include 50 in this. So we would say as long as I is less than or equal to 50. So we're going to start with 1, and we're going to continue, and we're going to include 50. So let's now log this to the console. Okay, so we're just logging the value of I. So if we save and we open this guy up, we check out the console, we should see it has now logged all of those numbers. So that loop repeated, and we counted all the way to 50. Boy, you could get a little bit crazy with this. Let's see what happens if we make it 500. We refresh. Now notice that it takes some time. Did you see that? You might have actually seen your screen blink a little bit, and you might have seen these numbers unfold. So it actually does take a little bit of time for JavaScript to process this. Not to mention, if we made it something outrageous like 5,000, it's actually going to take some time to process. Look, it was several seconds there before we got all the way to 5,000. So you can feel free to experiment. There might be a point to which it's actually going to say, hey, that's too much, and actually just the browser might automatically stop it for you if you give it too high of a number. That's not a challenge. Don't take that as a challenge to crash your browser. But anyway, it does take a little bit of time for loops to be processed. Okay, so now let's do another one. Let's create a loop that prints every even number. Ooh, there's interesting. Every even number between 3 and 25 to the console. So we're going to start I at 3, and we're going to continue as long as it is equal to 25. So we want to include 25. All right, now there's lots of different ways we could do this. On one hand, we could increment I by more than 1 each time. But we would then actually skip over the even numbers. So to do that would be a little bit fancy. Let's try to do it programmatically in here. Do you remember a way that we can test to see if a number is even? Think back to one of our earliest lessons when we talked about some of the basic operators, the mathematical operators in particular. Do you remember the modulus operator? That's the percentage sign, right? So we could say 5 percentage 3, and what that's going to do is give us the remainder of this division. So if we take 5 divided by 3, 3 only goes into 5 one time, and there's a remainder of 2, correct? So if we log this, we should see a remainder of 2 in the console. Let's take a look. Indeed. Okay, and actually we repeated that 23 times. Okay, so that's not what we really want to do, but I'm proving the point. So what happens then if we divide by 2? If we divide by 2 on, let's just say, let's console log I divided by 2. If we divide I by 2, notice that we get a 1 when it's 3, because there's a 1 remainder when we divide 3 by 2. But when we divide 4 by 2, and 4 is an even number, correct? We don't have any remainder. Same thing happens again when we get to 5. When we divide 5 by 2, we have 1 remainder. And 6 by 2, 0. 7 by 2, 1 remainder. So, bottom line, dividing or doing modulus 2 on a number will give us a 1 or a 0. And if it is a 1, we have an odd number. Otherwise, we have an even number. Let me say that again. We're using modulus to operate on the I. If we do I modulus 2, if the result is 1, we have an odd number. And if it's 0, we have an even number. So did you catch the conditional statement there? We could replace this with if I modulus 2, and we want to group it so that it gets there. Okay, if that is equal to 1, then we have an odd number, and we would say, oh, that's an odd number. So I'm going to print it and say that's an odd number. Okay, otherwise, we have an even number. So let's print it and say even. And let's just test it. Oops. Nice to spell things correctly, right? All right, so there you can see we can confirm it is working correctly, but we only want to see the even numbers. All right, so let's change things around a little bit. If I modulus 2 is equal to 0, we will just console log I. And we don't need to do anything for the odd numbers, so we just reduce it to this. And if I spell everything correctly, get a 0 in there. Okay, so we have succeeded at the loop. So you can see where part of this was setting up the bounds of the loop. How should this repeat? What's the counter? And then often in loops, one of the trickier things to just make sure we get honed correctly is what exactly we want to happen. So for each pass through here, for each iteration, we take I modulus 2, we compare it to 0. If it is 0, that means we have an even number, and we console log the even number. Otherwise, we do nothing, and we just repeat the loop. All right, so there you have some examples of loops. Now, let's try to work with this using a list. So first we want to move over this nice little array, which is a list, right? So we have an array of items, and if you just check out our page here, we have the potential of a shopping list. Okay, so maybe right below this we want to actually populate all of the items that are in this array. So what's the actual markup there? Okay, so here we have a list group, and it's just an empty UL. So maybe what we want to do is come in here and put some items, right? If I spelled it right. So I'm just going to put a couple examples in just to see the idea. All right, see how that works? And I think they need a class of list group item to make them pretty. Okay, so if we had a shopping list with 10 items on it, well, actually we have a shopping list with only 5 items here, so we could manually put those items into our markup. But behold the power of JavaScript. Instead of actually manually putting each of those in, what if we could use a loop? For each item in the list, actually add a new list item into our document. Wouldn't that be sweet? Well, let's give it a try. All right, so we've been given here a reminder of what was in the PowerPoint slide, so I'm just going to copy and paste this over. We'll talk through it. So the idea here is that we have a for loop, and we have a counter of I. As long as I is less than some array's length, we're going to increment I and do each of the following. Okay, so we're going to want to replace this array placeholder with the array we actually want, so the items array. So items.length. And then we're going to define each item on each pass. So that was in the slides. Remember, we called attention to that one. We had the variable before. Same idea here. The current item is the ith item out of items here. All right, so now we're going to do some other stuff here. But let's just see that we're on the right track. So we're going to go console log item. Okay, so what that should have done is gone to the ith item, which would be 0 at the beginning. And so we should take the string chicken and assign it to the variable item. And therefore, we should see the string chicken followed by each of the others one at a time. Chicken, eggs, milk, salt, sriracha sauce. All right, so we confirm that we're on the right track. Now, let's actually populate that list of items into the shopping list on the page. So there's going to be a couple steps here, but we've gotten a major part of this step accomplished by starting the loop and saving the current item into the variable item. So now what we want to do is create a new DOM element, which you may recall we do like this. We just create, we do a jQuery selector, but we put an actual tag inside of here. Not a tag selector, but an actual markup for a tag. I forgot to name my variable, so let's call it new item. And we are storing a jQuery object in this variable, so we use the $sign to remind ourselves of that. So now we can say new item dot text and pass in item. And because we wanted to add that nice little class so that it's formatted prettily, remember that, we'll go here, add class, list group item. Okay, so we have created a DOM object. Now, of course, each time we not only want to create the object, we actually want to insert it or append it onto our list. So how do we select that list? Well, it's the list group. Looks like it's the only list group. Yep, so we can just say list group dot append, because we want to put it not at the beginning but after any current content. So the first one is going to kind of just pop in there, but every one after the first one, we want it to go to the end of the list after each one, right? And then we just put the variable new item in so that that DOM object we created here, populated with the current items text, and that we added the class of list group item to it, we're appending each one into the list group. Okay, so with a few lines of code, we could have a list that's 5 items long or 5,000 items long, and jQuery and JavaScript are going to create our grocery list for us. Pretty slick, huh? Now you can begin to see why we do so much of this, because it's very easy and convenient, right? Okay, now we're going to switch back over to the slides and look at how to do this a little bit differently thanks to a jQuery functionality. And that is the each method. So since we often loop with a list of items that we selected with jQuery, in such cases we can use the each loop. So we're going to have a selector, or something that we have converted into a jQuery object, that is enumerable. That means that we could pass in here any array, any object, or even a string. If we pass a string in, then it's going to treat it like a CSS selector. So we could say select all of the LIs in our document, and for each LI we're going to repeat some code. Maybe we're going to add a button onto that LI or something like that. So we've actually done this already. If you might recognize this from some previous exercises, but now we're actually officially talking about what it is and how it works. So we start with some enumerable object, usually an array or some selection that results in an array. And then we have this structure that there's just a bunch of stuff here. So it's the each method, and it has a parenthesis set. So notice where the parenthesis opens right next to the each word, and it closes a few lines down before the semicolon. So what we're putting inside of this is a function that's going to be processed for each of the items in the selector set there. So what do we do with each item? Well, we have an anonymous function that runs, and it accepts 2 parameters. I, once again, representing the iteration, and O, representing the current object or the current item that we're working with. Okay, so those aren't any magical variables. You could name those variables anything you'd like, but I and O are very common. So let's take a look at how that could work here. So this step here says, let's try to duplicate the same idea using an each loop. So we're going to start with a jQuery selector, and then we're going to have the each. So I'm going to go back in and fill this in. What are we using as our selection? Well, we said that we could pass an array in here, right? Well, items is an array, so we can just pass items right into here. So this converts items into a jQuery enumerable object, which means it can be now passed through with the each operation. Okay, so then inside of the each we need the anonymous function, and we have I and O as parameters. So let's just console log I and O and see what we have on each iteration here. So I and O. So remember, we're looping through items, which would be this guy here. So I would expect in some fashion to see chicken, eggs, milk, salt, sriracha sauce, right? Indeed we do. So notice here's the I portion and here's the O portion. So I is 0 through 4, and O is the string that is stored in each of those items. Okay, so if we want to repeat the same idea down in here as we did up here, we could probably copy and paste. Except the only difference, I think, is that here we don't have items sub I. That's not really necessary because that is already stored in O. So we could just say items, item is assigned O, and then item is later passed down in here. Okay, so that keeps things very similar, and you'll see we'll now have a duplicate list because we have the original for loop running and then also the each loop running all over again, so we have both of them in here. But let me show you, we can make this just a hair shorter. Since we already have O in a variable, we can pass O here, and then we don't need this line. Okay, so the current object, the current item, not the iteration, but the actual content of the item is represented by O, so we pass O in as the text, and we get the same result here. All right, so you might think that I and O are really arbitrary and weird, so feel free to rename them. In this case, we could say this variable needs to be called item. Then we can use the name of item in here in a more meaningful way than just O. Okay, and the same result. So now let's favor the each loop. It's a little bit simpler, not so many strange pieces to remember. We just have the selector, and then I and O get passed in, and in this case we renamed O to item, and it works very well. All right. So there we have it, and we'll see some variations of this moving forward. But we have one more structure to talk about, and that is the while loop. You may recall that the very first slide had 3 bullets. The first addressed using a counter, the second addressed using a list as a counter. The third one talked about this more loose type of structure where we really just have a condition, and the loop is going to continue as long as that condition is true. So here's what that looks like. This is called a while loop, and what we do in placeholder I is place the condition. And then in placeholder 2 we put the code to process. But remember, it is very easy to create an infinite loop on accident if we are not accounting for the possibility of the condition changing inside of placeholder 2. So there might be some point in placeholder 2 where we would change some variable that eventually makes the condition in the opening part there become not true and thus discontinue the loop. I don't really use while loops very much, but they are out there and I wanted to make sure that we covered it. So there you go. All right, good luck on the exercise.